Hey, what's going on, guys? Today we're going to learn how to calculate the distance between 2 points using the distance formula. Here it is. Hey guys, before we start, I just want to make it very clear that the distance formula is actually derived from the Pythagorean Theorem. And the Pythagorean Theorem turns out to be a much more intuitive way to calculate distances. But I'm going to save that for a different video, and I'm going to make this video for those of us who are unfortunate enough to be required to memorize this distance formula. Alright, so in a different video, I'll sort of explain where this comes from and how to calculate these distances a bit more intuitively. But for this video, we'll just stick with the formula, what it is, how to use it. Alright, so why do we need the distance formula in the first place, you may be asking. And you might be thinking, well, can't I just count how far away the points are? And that's absolutely true if your points happen to be vertical, completely vertical, right? If your points are completely vertical like these two are, well, then I can just count that they are 1, 2, 3, 4 away. They're 4 units away. And similarly, if I had 2 points that were perfectly horizontal from each other, then I can simply count 1, 2, 3, 4, 5. These 2 points would be 5 units away. But where we run into trouble is when our points are diagonal from each other, because our coordinate grid provides means of counting vertically, and it provides means of counting horizontally, but the coordinate plane does not provide means of counting diagonally. And so we can't just sit here and count how far away these 2 points are, and that's what the distance formula is for. Alright, so the first presentation you might face is a coordinate plane with a couple of points on it. You're asked to calculate how far away they are. And the first thing you need to do is identify your points. Alright, so this one here is going to be 1, 2, 3, 4, 5, 6, -2. And this point here is going to be -1, -2, -3, 1, 2, 3, 4, -3, 4. Alright, and then here's the distance formula. So your distance is going to be equal to the square root of your x value subtracted squared plus the quantity of your y value subtracted squared. And if you're aware of the Pythagorean theorem, you could possibly see where this is coming from already. But again, I'll save that for a different video. And so really the hardest part about this is correctly substituting all of your values. That's the hard part. From there, you just number crunch. And so the first thing you want to do is identify your x sub 1 and y sub 1. So it doesn't matter which point you pick. I can make this x sub 1, y sub 1, or I can make this x sub 1, y sub 1. What you can't do is mix and match. So I can't call this x sub 1 and then call this y sub 2, for example. The subscripts have to be the same for each set. So I'll call this x sub 1, which means I have to call this y sub 1. And then that means this is going to be x sub 2 and y sub 2. Alright, and now we're just going to go ahead and substitute. And so x sub 2 I said was -3. And then we are going to subtract x sub 1. So that's going to be 6. And then we square that. Alright. And then we add to that y sub 2, which we called 4. And then we subtract from that y sub 1. So y sub 1 in this case is -2, so we're subtracting -2. Subtracting -2. Okay, we square that, and then we take the square root of the whole thing. So now, honestly, I think that's the hardest part right there. So now we just have the number crunch. And so -3 minus 6 is going to be -9. So that's how this set of parentheses breaks down here. And then 4 minus -2, that's the same as 4 plus 2, so that's going to be a +6 squared. All right, so all I did was simplify the two sets of parentheses here. And now these parentheses are very important because the negative sign here is within the parentheses, which means -9 squared is going to be -9 times -9, which gives us a +81, right? Again, -9 times itself, so it's negative times negative, that gives us a positive. And then that, of course, is just 36. All right, and then that's going to give us the square root of 117. Now, this is an exact answer here, but if you're asked to put this in simplest radical form, then we could, of course, do that. And so the largest perfect square that goes into 117, I believe, is 9. Right? And then that's going to go in 13 times, right? And then the square root of 9 breaks down to 3. And so this is going to equal 3 root 13 if you're looking for simplest radical form. But again, this is technically a correct answer. And then just to sort of make sense of how far that is in terms of units, if you were to go ahead and type this into a calculator, right, 3 times the square root of 13, you would get approximately 10.8. And so the distance from this point to this point is about 10.8 units. So if we were able to take one of these squares, in these grid squares, and sort of turn them diagonally and then line them up, we would fit 10.8 of them approximately between the two. And that's actually a good illustration of why we can't simply count these, right? Because we can't count 0.8 of a unit, at least by hand. All right, so here is another way that these problems might be presented, where they just simply ask you to calculate the distance between 2 points, and they don't give you a coordinate plane or anything like that. They just give you the points. And it's this presentation that sort of forces you into memorizing this formula, unfortunately, because again, I happen to have graph paper here, but on a test, maybe you don't have graph paper and you just have these points, in which case you're sort of incentivized to just use the formula here. But the process doesn't change. So we need to establish what x sub 1 and y sub 1 are. So since this comes first, I'll just call this x sub 1, y sub 1. And I'll call this x sub 2, y sub 2. And then we just go ahead and make our substitutions. And so x sub 2 was 4, right? And we're going to subtract x sub 1, so that's minus 10. And then we're going to take y sub 2, which is negative 4. And we're going to subtract y sub 1, which is 2. Okay, so all I've done here is substitute. It's the same exact expression, except instead of variables, I've just substituted in my numbers. And now we can go ahead and number crunch. So 4 minus 10 is negative 6. Again, you got to keep those parentheses. And then negative 4 minus 2 is going to be negative 6 again. All right. And now we'll see the importance of these parentheses now, because now we see that we get, under the radical, we get 36, positive 36 plus positive 36. Right, if we didn't have those parentheses there, then we would have had negative 36 plus negative 36. Then we'd have a negative value under the radical, which we don't want. And this, of course, equals the square root of 72. And the largest, so this, again, this is an exact answer. It's absolutely correct. But if you want this in simplest radical form, the largest perfect square that goes into 72 would be 36. And the square root of 36 is, of course, 6. And so this is going to be 6 root 2. Or you can go ahead and type that into a calculator, and you end up with approximately 8.5 units. So the distance between these 2 points is roughly 8.5 units. All right, and we'll call this one done.